All right, Ms. Way, some good evening again. I see where Ms. Green somewhat got disconnected. I hope she'll be back soon. All right, so I want to give her a little time to get in, but let me have a little discussion on this topic. Maybe she'll join back in short order. All right, so coordinate geometry is related to graph. Now, if you had been paying keen attention to some of the processes in mathematics, you'll realize that when you actually carry out a process to do one thing, you can actually reverse that process to go back to where you're coming from. For instance, when we looked at removing brackets, we multiply out what is in the brackets by what is outside. So that law is a distributive law. But when you actually factorize, you're actually reversing that process. So in math, there are many situations like that where you kind of reverse the process. So we have been looking at graph from the previous class. And so coordinate geometry, I'd like to consider it as kind of a reversal to what we have been doing in graph, but not entirely. But you will make a little connection there as we move along. All right, so the word coordinate geometry should tell you something. You look at the word coordinate, what comes to your mind? And when you think about geometry, what comes to your mind? Give me an idea what comes to your mind, Ms. Waysome, when you hear coordinates and when you hear geometry.
Coordinates would be like the points, sir.
All right, yes, like the points. But so it would be the X and Y values that denote a point, all right, because we actually mark a point by using the X and Y coordinates. All right, so that's exactly what the coordinates is about. It's about the geometry now.
The geometry, some having to do with measurement.
All right, has to do with measurements. Anything else from geometry?
Thinking about it, sir.
If you can come up with anything, you should let me know so that I can enlighten you.
Well, sir, coordinate points, as we say, measurement, like, for instance, so like, would I have point A to point B? So, you know, we don't know, sorry, we cannot have it understand, but we just don't know how to explain it.
Okay, so all right, so geometry in mathematics is that area in math that really deals with shapes. And when we talk about triangles, squares, all of those, we call all of those regular shapes, but we also have irregular shapes. So and those have to do with measurements and so on, dimension, volume, area, all of those fall under the area of maths that deals with geometry. So that's what geometry really deals with.
Okay, so
when we say coordinate geometry, coordinate would suggest that we're doing something on a graph. And so coordinate geometry really indicates that we're doing geometry with coordinates on graph. So that's what it is really about. So we're really looking at what we can do with the coordinates on a graph. Can we create a shape by plotting points? So there are a number of things that we should be able to do with these coordinates in terms of geometry. So that's what we'll be looking at today. All right, so we can recall that geometry deals with angles, shapes, and dimensions. Now, coordinate geometry is the use of coordinates to plot shapes on which calculations and analysis may be done, carried out in various ways. So depending on what is asked of you, sometimes they might ask area, you may be asked about volume, but if it's a circle, you may be asked maybe circumference or something like that. But whatever is asked of you, it will be related to graph and points. All right, so we're looking at our first example here. And so this is asking us to plot the points A, B, C, D, and join them, join up the points in alphabetical order to form a quadrilateral. All right, so that's what we'll be doing. So we are going to look at plotting this shape based on these points. So of course, in order to plot these points, you really need to have a scale on your graph. Now, how do you determine what your scale should be? Well, you would have to look at the coordinates. You know that the first number in the bracket would be the x coordinate. And so if you look at, say, point A, so the x coordinate here would be 3, and the second coordinate, which is 4, would be the y coordinate, right? Now, if you look at all the points and you look at the x and y values, what you want is first to see whether or not your x and y values have any negative. So that would indicate that you would have to have a negative side to your axis. But if you don't have any negatives, it means that you don't need the negative side of your axis. Now, so for these values, you notice that they're all positive. So in fact, then you only need above the x-axis where y is positive, and you only need to the right of the y-axis where x is positive. All right, so first we need to now determine what is the largest value of x, so we can extend our x-axis to accommodate that largest value of x. So if you look at the x coordinates, you see we have in A, x equals 3, in B, x equals 5, in C, x equals 6, and these are positive, and in D, x equals 2. So what would be the largest value of x here?
6, sir.
6. So it means that on your x-axis, you must be able to accommodate values up to 6. So I would say make your scale that it can go up to about 7 or 8 so that you can accommodate the highest x value. And likewise, on the y-axis, you will do the same. So look for the largest value of y. So for A, the point A, the value of y is 4. Point B, value of y is 4. Point C, value of y is 2. And point D, value of y is 2. So what would be the largest y value here? What would be the largest y value in this? The screen?
4, sir. Oh!
All right, so that would suggest that on your y-axis, you only need to go up a little bit more than 4. So I would say you can go scale so that you can go up to about 6 or so on your y-axis. So that's the first step. So after you have made your scales, or after you have made your scales, then the next step now is to plot the points. All right, and so based on my x and y axis here, then you would find that if you count along the x axis for this point D, you'll count, go to 2, And then now you'll find the y value, which is 2, and then now you plot the points as though you would normally plot when you're plotting graphs in general, right? And you do that for all the points. So you come x equal 3, and you go up y equal 4 for this value, or this point at A. All right, so that would be x equal 3, y equal 4 would come across that. All right, so once you're plotting your points, after you plot your points, then now you connect the dots, and then now you will have your shape. All right, now if we go back to what the question was actually asking us for, now the question says, plot the point A, B, C, and D. Join up the points in alphabetical order to form the quadrilateral. Now, this is what you are to do. You are to name the quadrilateral. Say what the quadrilateral name or what type of quadrilateral it is. B, then find the area. All right, so that's what you're supposed to be doing for this question. So the first task is to plot your shape. The next task now is to name the shape, what kind of quadrilateral, and then find the area. Any suggestion? What about, let's start off with the name of the shape first. Anybody know what this shape means? Why is it called a quadrilateral anyways? Anybody?
4 sides, sir. Is it a trapezium, sir? I'm sure.
You are supposed to tell me whether or not it is.
Sir, I'm not sure. I don't remember, but we know they have one. I'm not sure for certain.
What about you, Miss Green? You agree with Miss Waysam? Miss Green, are you there?
Yes, sir.
So what do you think? Is it a trapezium?
Looks so, sir.
Okay. All right. So it's either you know it or you don't know it. Now, a trapezium has certain properties. And if you don't know what the properties are, then you won't be able to identify it. So what would be the property of a trapezium? So let me first answer your question. Yes, it is a trapezium, but we want to see why we call it. What are the properties that makes it a trapezium, right? Now, a trapezium has 2 sides which are parallel. Now, what do we mean by parallel sides? Now, you want to answer that question, Mr. Isam? Go ahead.
Yes, sir. I was saying that they're running in the same direction.
All right. So we generally use arrows to denote their direction. Now, so they are generally going in the same direction. And what else about them?
The same space in between, sir.
All right.
They maintain the same space in between.
So the distance between them is
Yes.
constant. Now, what do we mean by the distance being constant is that the lines never drift away from each other and the lines never come close to each other. So in other words, the line never diverges and the line never converges. Now, what do we mean by diverge? Now, if we have 2 lines that are going in the same direction, but one line seems to be going diagonal up and the other one seems to be going diagonal down, then you notice that they are moving at an angle away from each other. And the further they go is the wider apart it becomes. So in this case, the lines are diverging. Now, if they instead were moving at an angle towards each other, then we say that the lines are converging. Now, with converging line, eventually those lines would cross at a point, right? So for parallel lines, they don't diverge and they don't converge, but they maintain the same distance between them no matter how far they go. Is that clear to you?
Yes, sir.
Right, so for a trapezium, you have two parallel sides and two sides that are not parallel. So if you consider the side from A to B and the side from B to C, would we consider these sides to be parallel?
No, sir.
Why?
So they're going different direction, and as you see, they might go different directions, sir. But when they might travel, the space in between them stay might go wider. More space may eventually come in between, so you're not going to stay steady as the one parallel traveling would be.
So I had mentioned what they moving apart. What did I call that? Starts with a D.
Diverge, sir. They don't
Right. So they are diverging.
Yes, sir.
So because they are diverging, they cannot be parallel. All right. All right. So if you get the idea now about parallel lines, then when we talk about a trapezium, we say that a trapezium is a four-sided figure with two sides that are parallel and two sides that are not parallel, are opposite sides. If you want to put it this way, opposite sides are parallel. So the side above would be opposite to the side below. So these sides are parallel. And the other opposite sides, so you have two parallel opposite sides and two sides opposite, which are not parallel. All right. So that's the property for a trapezium. So that's what makes it a trapezium. So whenever you see any shape like this, you should be able to identify it as a trapezium. All right, any question? All right, so the next part then, so we would have named the shape. So we say it is a trapezium. What else can we say about the shape? We want to find the area. Now, what do you know about the area of a trapezium? Let us go back and look at the shape. What do you know about the area of a trapezium? Anything come to your mind, Miss Wilson, Miss Green? All right, so let me work that out for you then. Now, the area, there's a formula that gives the area of a trapezium. All right, so for your sake, you only need to know the formula. Now, we talk about the sides that are parallel, the opposite sides that are parallel. Now, if you notice, these opposite sides are not really same in length, even though they are parallel. So what we generally do is to label one of the side A, which can be the shorter side, label it A, and the longer side we label B. Now we also need to know the height, or should I say the distance between the parallel sides. So if we consider the distance between the parallel sides, we want to know, in this case, it would work out to be the height between them. All right, so if you, and this would be a perpendicular line, or it would be a vertical line, which would be perpendicular to the horizontal line. All right, so what this says then, now this distance between them remain constant. Now in this case, we'll refer to it as the height because of how the diagram is shaped. But in some cases, you could just refer to it as distance. But the formula is generally with h for the height, all right? Now from what we have here, we have the length of the parallel sides. One side is A, one side is B, and we have a distance between them, which is h. So the formula for area of a trapezium would be similar to the formula for triangle. So it is half the sum of the parallel sides. So it's half A plus B, and that you put in brackets. So you add the two parallel sides in brackets times the height. Now, when you think about the area of a triangle, it is half base times height. But in this case, we can think of the base more like the sum of the two parallel sides. So that's the formula. So if we are going to be using that formula to calculate the area, do you have any way that you can determine the length of A and the length of B and the height? Is there any way you can figure out that based on the coordinates? Can you make any calculation?
Sir, I was looking at it and I was wondering if it would fall like the first one is 2 to 2. What do you have to say?
When you say the first one, what are you referring to?
D. All right, so D was a 2. No, sir, but I think it all makes sense.
Now, what you need to find is a value for A. You need to find a value for B. You need to find a value for H. Now, can you use these sides of the trapezium to determine what A should be and what B should be and what H should be?
Well, right, so that is what I was, so sir, all right, A and B. So A and B would have been from point A to B. That little part there, so sir, someone I say we could have probably put like dotted line come down to meet the x-axis.
Right. So
and
from here you could
right to meet, yes.
Way down. Yes, you can do that. And then you carry another dotted line there. Come down.
Yeah. Yes, sir.
And then you would make a calculation.
Yes, sir. But you would have tried it out to the y as well, right, sir?
Yeah, you could do that. But that would be pretty, kind of a little bit more tedious way to do it.
Okay.
There's an easier way to do it. Look at the x values, because you know these are horizontal lengths, so they are measured along the x-axis, right?
X-axis, yes, sir.
So you look at the x value or the x coordinate in the first point of A. You look at the x coordinate in the first point of B. So those are the x coordinates. So remember now, this 5 here starts at 0, come all the way up to 5. This 3 here starts at 0, come all the way up to 3. So what it means then, you can simplify an A by doing what?
Adding 5 and 3?
No.
It'll take away, sir?
You're guessing? I don't want you to guess.
No, when we look at it now, sir, may I say that maybe take away.
This is 5.
Yeah.
This is 3.
Yes, sir.
And from here to here is say A.
Right. So sir, you the right to the 2 then the sir, you have take away, sir.
Yes, so you take away the smaller one from the larger one.
Yeah.
So you would, to get A, you would actually have to subtract 3 from 5. All right, so this length here, 5 minus 3, and what you get?
2, sir.
2. That means A would be equal to 2. What would you now get for B?
So B, 2 and 6, 4, sir.
All right, so using the same x coordinates, so you take away 2 from 6. And that equal to 4. All right, so now we know a value for A, and now we know a value for B. How about H?
Repeat.
How can we find the value for H? So now H is running along the y-axis. So now you have to consider the values for y.
In 2 and it would fall between 2 and 4, sir.
So what you're going to do?
Sir, that like a add.
No, it wouldn't be add, still subtract. So you take away the smaller one from the larger one. Right? Because remember, no, the height does not start down the bottom, go all the way up.
True, sir. Me just get that part there, really.
All right. So this now you take away 2 from 4, you have 2.
2.
So now that we have the values of in the formula of AB and H, we can calculate the area as half. So the area would be half. The sum of 2 values would be what now? A and B would be what?
2, sir.
2 plus
4.
4. Times the height.
Yes, sir.
So the height here would be 2.
2.
All right, so if you do that calculation, you work out what is in the bracket first. So you would have times 4. Sorry, times 6, because 2 plus 4 equals 6. And then times 2.
Yes, sir.
Now, you can easily cancel this 2 with this 2.
Yes, sir.
And you only have 6 remaining. This now give you the area of 6 square units. And so that's how we would work out the area for the trapezium. Is that clear, guys? Now you may see this trapezium in other contexts apart from coordinate geometry. You may just see the shape by itself as a question, and they ask you to work out the area. It's the same formula that you use. You just need to know what the length of A is, the length of B, and the height. All right. Any question? Is that clear to everyone? Yeah, good.
Sir, can you go through it one more time, please?
Okay. All right. So the first thing that you want to do is to remember the formula. Now the formula is the area is equal to half times the sum of the parallel sides times the distance between the parallel sides. So you have that down, Miss Green, right?
Yes, sir.
Right. So the next thing to do now is to work out the value for what A is, what B is, and what H is. Now, the value for A has to do with the length of the shorter parallel side, right? Now, to get that length, you look at the x coordinates at those points. So the x-coordinate at A would be 3, the x-coordinate at B would be 5. Now you subtract the 3 from the 5. So the smaller one, you subtract it from the larger one. So when you do that, 5 minus 3, you get 2. So that value would now be A. Following?
Yes, sir.
Right, now the same thing you would do for this side, which is the side B, because that is measured along the x-axis just the same. So you look at the x-coordinates in both points. So you see the larger one is 6. You subtract 2 from 6. So we would get 4. So that would be the value for B. And now for the height, now you're going to look at the y value. If you look at the y value at A, and you look at the y value at B, you have 4 at A, which is the larger one, 2 at B, which is smaller one. Now, because it is parallel, the height at C would be the same as the height at D. So you have 2 at D2 and you have 4 at D. So it's the same height. So all you have to do is just take away 2 from 4 to get the height. And so in that case, you get the height to be 2. Now, once you get these values, the value for A, the value for B, and the value for H, you plug those in the formula where you have A, B, and H. So you put, where you have A, you put 2, where you have B, you put 4, and where you have H, you put the 2 for the height. Then now you're going to do a calculation, work out what is in the brackets first. So you add what you have in the brackets. So 2 plus 4, you get 6. So you write back the half times 6. Now remember you have a 2 out here, which is you're multiplying by. So it's times 2. See that? Give me a second. You following? Miss Green?
Yes, sir.
Right, so you would know you can cancel. So you cancel this 2 with this 2. So all you have remaining is a 6 here. So that gives you 6 square units. And that's all there is to it. So you're good with that now?
Yes, sir.
All right, so with that said, we can clear what we have here and continue. All right, so it means that our answer would be a trapezium for the name of the shape, and our calculation for the area, we use that formula. We calculate the height and the parallel sides and the height, and we now put those values after we have done our calculation.